Let's look at some examples on how to solve logarithmic equations. So a logarithmic equation is an equation containing a variable in a log expression. So again, there's different ways to deal with these, but one of the most common ways to deal with a log equation is to try to convert it to the exponential form, because we're much more comfortable working with exponents. We've been doing it a lot longer. So we try to convert to that exponential form. Now, remember, I just wrote it over here for you guys, what that looks like. So you take your original log form, and then remember that whatever you're equal to is always the exponent, and your base stays the same. So in the exponential form, you have your base to the c power is equal to, in this case, m. So let's apply that here. So I see I have the log form. Here's my base. Here's my exponent. So if I convert that over, I have that 4 squared is equal to x plus 3. Now this becomes an equation that I'm much more comfortable with. Well, 4 squared is 16. I can subtract 3 from both sides. And I have x is equal to 13 here. You do want to get in the habit of checking your answers in general with logs. You do, because it's just little things to watch out for. You have to watch out for domain restrictions and things like that. So here, if I plug in 13, I have log base 4 of 16 equals 2. So in the exponential form, that says that 4 squared would equal to 16, which is correct. So you do want to make sure that, again, there's no domain issues. Remember that for your domain, this has to be positive. So you do need to make sure that x plus 3 is greater than 0. So in this case, x would have to be greater than -3, which it is. So just make sure you do that check at the end here. It is a lot more important with logs just because of that domain issue in particular. All right, let's do another one here. Now notice that I have an extra number out front. Normally when we convert over, there is no coefficient, it's just a 1 there. So I do want to use the power rule and rewrite this. So before I get started, I'm going to go ahead, sorry, not the power rule. I'm going to use my quotient rule here, and I'm going to rewrite this by solving and getting that natural log by itself. So here, I'm going to get rid of that 3. And what I can do is it's just being multiplied here. So the easiest thing to do is just divide it on both sides by 3. So I have natural log of 2x is equal to 4. So if you have something extra that's going on in your log equation to start, see if you can get rid of it. And again, try to do it the easiest way possible. So in this case, like I said, you can divide those both by 3. It's just being multiplied here. So 12 divided by 3 comes out to be 4. Now, this is going to be our exponent. And remember that your base here is e. So when you have that natural log, your base is e. So we're going to go ahead and set this up to be e to the 4th power is equal to 2x. I can divide both sides by 2 here, and I get a final answer that x is equal to e to the 4th over 2. Now that's the exact answer. If you want to see an approximation, we can use it on our calculator. We get about 27.3. Again, just as a check, you can try that at home. And you do want to plug it in to make sure it is true. So I will note here, that in this example, you want to check your domain. You would need to make sure that 2x is greater than 0. So x would have to be greater than 0 here if you divide these both by 2. Clearly, this is the case. But if you plug that in, you will also get that same result. So if I check this, I have 3 times the natural log of 2 times e to the 4th over 2. 2 over 2 is going to cancel. So I have 3 times the natural log of e to the 4th equals 12. Now, what happens here for this part, that natural log and e part basically cancel. They give you a factor of 1. So just that 4 is going to come down. I end up with 3 times that 4 equals 12, which is true. So that check does work here. And again, we're just checking our domain as well, making sure that there are no additional restrictions. All right, let me do another example. Now for this one, in order to use that exponential form, I can only have it with one log. I have two logs here. What do I do? So think back to some of our properties. And we learned before that when you have addition, that means that the original log was being multiplied. So I'm going to put this actually back together first. And I do have the same base, so I can do that. So I'm going to write this as log base 2 of x over x minus 7 equals 3. Oh my goodness, what am I doing here? That's for subtraction. Say, Professor Pollard, you're doing it wrong. Log 2 of x times x minus 7 equals 3. I apologize. So when you have addition, I think I said this out loud, I just wrote it wrong. I hope so. I said that you're going to actually multiply, right? That means the original values were multiplied. So you have the x times the x minus 7. Now, if you want, you can clean this up a little bit, just to kind of rewrite it, because we're going to keep solving anyway. So this becomes x squared minus 7x. And now I have it in a single form. So now I have one log. Here's my base. Here's my exponent. So I can rewrite it now as 2 to the third power is equal to x squared minus 7x. 2 to the third is 8. I'm going to keep solving. I'm going to bring everything to one side. And I'm going to notice now that I have a quadratic that I can solve. So x squared minus 7x minus 8. Now for this one, I am going to use the factoring strategy. You could also use quadratic formula. It's going to factor as x plus 1, x minus 8 here. And then I'm going to set each factor equal to 0. So x plus 1 equals 0, x minus 8 equals 0. And then I'm going to subtract 1 from both sides. I get x equals -1, add 8 to both sides, and I have x equals 8. So I have my two solutions. Again, be really careful. Notice here that, remember, for our domain, you do need to have that each of those parts is positive. So you would need that your x values are greater than 0 to satisfy the first part. And then for the second part, you would need that x minus 7 is greater than 0, or actually x is greater than 7. So I have these two domain restrictions here. And we're going to see that one of them is not going to work, right? This -1 is not going to work. I'm not even going to plug it in. When I plug in -1 here, it's less than 0. It doesn't fit in the domain, so it's not going to be a solution. When I check x equals 8, so I don't see any initial domain restrictions. It looks good, right? It's greater than that 7 value. It's greater than 0. So I have log base 2 of 8 plus log base 2 of 8 minus 7 equals 3. Excuse me. Think about these two parts individually for a second. So if I think of log base 2 of 8, I'm trying to solve log base 2 of 8 equals x. So 2 to what power would be 8? And the answer would be 3 here. So log base 2 of 8 is just 3. And then here, you're looking at log base 2 of 1 equals x. So we're saying 2 to what power would be 1? And the answer there would be 0. So remember, when you're having a 1 here as your argument, the value is going to be 0 because that's the only thing, the only exponent that makes the answer 1. So this becomes 0. So I have 3 plus 0 equals 3 for my equation, which is true. So you have one solution here, that x equals 8. So again, with those log equations, just be really careful. There's a lot of opportunity for domain issues in particular, making sure your base obviously is positive as well. But those domain issues, you really have to watch out for those. Sometimes we do get those extraneous solutions when solving. All right, let's do one more strategy here. for solving log equations using what's called the one-to-one property of logs. So it's very similar to the exponential property, where if the bases are the same, then you just use the two exponents to solve the equation. So here, if you can get the logs to be the same, right? So log with the same base, then you can set the m and the n equal to each other and solve. And of course, just make sure to check your answers. You really want to watch those domains for logs. And again, notice that you're in log equals log. So there's no numbers out front. It's as kind of simple as it can get there. So let's look at our example here. First of all, I do see that all my logs have the same base, which is good. I need that, or else I can't combine or rearrange anything. So I have natural log in all cases. But I need log equals log. So I need to actually find a way to put these back together and condense that. So remember that subtraction means division. So I can rewrite this as the natural log of x plus 2 over 4x plus 3 equals the natural log of 1 over x. So here's a great piece where that property comes in, that is helpful, where I can put those logs back together here to solve. Now I'm in that correct form. I have log equals log, same base. So we're actually going to solve the equation x plus 2 over 4x plus 3 equals 1 over x. Now, there's different ways to think of this. You can either think of it as a cross-multiplying technique, if you're familiar with that, that would work here. Or you can think of it as a rational expression problem or equation problem where you're solving. So what you could do is you would multiply both sides by x to cancel this denominator. And then you'd multiply both sides by 4x plus 3 to cancel the other denominator, right? So that would cancel this one here, and that would cancel your x. In either case, you're going to end up with x times x plus 2, and then 1 times 4x plus 3. And you can see it much easier in that cross multiplication strategy instead here. I'm going to keep simplifying. So I have, let's see, x squared plus 2x. And then here it's going to be 4x plus 3. I'm going to subtract the 4x to both sides. I'm also going to subtract that 3 to both sides too. Just kind of do those steps together here. And what I have is x squared minus 2x minus 3, and then equal 0. Now I have my quadratic. So I can either solve by factoring, or I could also use the quadratic formula here. This is factorable, so I'm going to go ahead and do that. And I'm going to have two answers here. So I have x plus 1 equals 0 and x minus 3 equals 0. Here I subtract 1 from both sides. Here I add 3 to both sides, and I have my two solutions. Now, again, you just want to be really careful here. First thing I would go ahead and check are those domains, okay? That would be my first case. So here you need to make sure that this is greater than 0. So if I subtract 2 from both sides, you have to make sure that x is greater than -2. So that's one issue. Both of these are actually met there, so I don't have any domain issues yet. I have to do my other domain too. I have to make sure that 4x plus 3 is greater than 0. So I subtract 3 from both sides, and then I divide by 4. So I have to make sure x is greater than -3/4. Now I do have an issue here already. So -1 is not greater than -3/4. It's smaller, right? It's actually more negative. So I can tell you right away from my domain issue that this has to be thrown out. Okay. And then I do need to make sure that this is also greater than 0, and also that the x value is not 0. And if I have a little bit easier here, if I plug in 3 here, I get 1 over 3, which is positive. So I don't have a domain issue restriction here with 3. So it looks like 3 is our only solution. You can still formally check this. So I would have natural log of 3 plus 2 minus natural log of 4 times 3 plus 3 is equal to the natural log of 1 over 3. So natural log of 5. Here, let's see, 4 times 3 is 12, plus 3 is 15. Now think about your rules here. Subtraction means that these were originally being divided. So this is the natural log of 5 over 15 equals natural log of 1/3, but 5 over 15 is 1/3, so this does check out. You could also use your calculator here to check. So let's say you got to this point and you didn't recognize that you could put these back together. You could use your calculator. So if I plug in, let's see, the natural log of 5 minus the natural log of 15, I get that value. And if I plug in the natural log of 1/3, I get the same value. So I can also check using my calculator and making sure that I get that true statement on both sides. Again, for your checks here, the big thing is going to be the domain. So once you've checked all the domain issues, I don't think you're going to see any other problems typically. It's still good to get in the habit of checking anyway, but I would use my domain issues to exclude values first. I think that would be a little bit faster.